Rock, paper, scissors is a popular game that has been enjoyed by people of all ages for generations. People play it all around the world, from playgrounds to offices, and even in international competitions. It is a hand game that is simple to learn but can be surprisingly strategic. Two or more people can play, making it a versatile game for any group size. Each person makes a hand gesture, choosing between rock, paper, or scissors. The gestures are rock, paper, or scissors, each with its own unique shape and meaning. They make the gestures at the same time. Rock beats scissors, scissors beats paper, and paper beats rock. This creates a cycle where no one gesture is always the winner. It is a fun and simple game that brings joy and laughter to many. People of all ages play rock, paper, scissors, from young children to grandparents. It is a great way to have fun with friends and family, creating memories and bonding moments. It is also a good way to make decisions, especially when you need a quick and fair method. For example, you can play rock, paper, scissors to decide who gets the last slice of pizza, or who goes first in a game. Learning to code this game in Python can teach you valuable programming concepts such as loops, conditionals, and user input. You can use these concepts to build other games, enhancing your coding skills and creativity. In the next section, we will learn how to code a simple round of rock, paper, scissors in Python, step by step. This will be a fun and easy project that will give you a sense of accomplishment. Let's get started. Let's code a single round of rock, paper, scissors. We will use Python, a versatile and beginner-friendly programming language. Python is a great language for beginners because of its simple syntax and readability. It is easy to learn and use, making it perfect for our rock, paper, scissors game. First, we need to import the random module. This module is essential for generating random choices for the computer. The random module will help the computer make a random choice, simulating the unpredictability of a real opponent. Now we need to get the user's choice. This is where the game becomes interactive. We can use the input function for this. It allows us to capture the user's input directly from the keyboard. Next, we need to get the computer's choice. This will be done using the random.choice function. The random.choice function will randomly select between rock, paper, and scissors for the computer. Now, we need to compare the user's choice and the computer's choice to determine the winner. We can use an if statement for this. If statements allow us to execute different code based on conditions. If user_choice equals computer_choice, print it's a tie. This handles the scenario where both choices are the same. If user_choice is rock and computer_choice is scissors, print you win, rock beats scissors. This is one of the winning conditions. Add other winning conditions here, such as paper beating rock and scissors beating paper, else print you lose, computer wins. This covers all other scenarios where the computer wins. That's it. We have coded a simple round of rock, paper, scissors in Python. This basic structure can be expanded for more complex games. In the next section, we will learn how to play multiple rounds, adding more functionality and excitement to our game. We can easily play multiple rounds of rock, paper, scissors, making it a fun and engaging experience for everyone involved. To achieve this, we can use a loop in our code. A loop is a fundamental programming construct that allows us to repeat a block of code multiple times, ensuring that our game can continue seamlessly. Specifically, we will use a while loop for this purpose. A while loop continues to execute a block of code as long as a specified condition remains true. In our case, the condition is that play_again equals true. While play_again is true, the code for a single round of rock, paper, scissors will be executed here. After each round, the user will be prompted with the question, play again? YN. If the user's answer, converted to lowercase, does not equal Y, then play_again is set to false and the loop will terminate. This code structure ensures that the game will keep playing until the user decides to stop by entering and when asked if they want to play again. This makes the game more interactive and allows players to enjoy multiple rounds without restarting the program. The user has the freedom to decide how many rounds they want to play, making the game flexible and user-friendly. In the next section, we will delve into using enum for action descriptions, which will add another layer of sophistication to our game. This will make our code more robust, easier to maintain, and enhance the overall gaming experience by providing clear and consistent action descriptions. We can use enum to represent the actions in our game. Enum is a class in Python that allows us to create enumerated constants. These constants are more readable and less error-prone than using strings. From enum import intenum, class action intenum, rock equals 1, paper equals 2, scissors equals 3. Now we can use these constants in our code. For example, instead of if user underscore choice equals rock and computer underscore choice equals scissors, we can write if user underscore choice equals action rock and computer underscore choice equals action scissors. This makes our code more readable and easier to maintain. Section 5. Flowcharts for planning. Flowcharts are diagrams that represent a process or algorithm. They are useful for planning out code logic before writing it. You can use flowcharts to visualize the steps involved in each round of the game. A flowchart for rock, paper, scissors would include steps like first, get the user's choice, then get the computer's choice. Next, compare the choices, determine the winner, and finally, ask if the user wants to play again. Using flowcharts can help you write better code. It can make your code more organized and easier to understand. Section 6. Organizing code with functions. We can use functions to organize our code. A function is a block of code that performs a specific task. We can define a function to get the user's choice, another function to get the computer's choice, and another function to determine the winner. For example, Python def get underscore user underscore choice. Using functions makes our code more modular and reusable. Section 7. The Lizard Spock expansion. We can expand our rock, paper, scissors game. We can add 2 more options, Lizard and Spock. This variation is from the TV show The Big Bang Theory. Here are the rules for Lizard and Spock. Scissors cuts paper, paper covers rock, rock crushes lizard, lizard poisons Spock, Spock smashes scissors, scissors decapitates lizard, lizard eats paper, paper disproves Spock, Spock vaporizes rock, and rock crushes scissors. We can implement these rules using a dictionary. A dictionary is a data structure that stores key value pairs. We can use the actions as keys and the actions they defeat as values. For example, Python rules =, or winner =, none if user underscore choice, =, computer underscore choice, elif computer underscore choice and rules user choice. Else. This code expands our game to include Lizard and Spock. It makes the game more challenging and fun. Section 8. Playing against the computer. Our code currently assumes 2 players are making choices. We can modify it so the user plays against the computer. The computer can randomly select from the available actions. We already have code to generate a random choice for the computer. Python def get underscore computer underscore choice, choices =, action, rock, action, paper, action, scissors, action, lizard, action, Spock, return, random.choice, choices. This function allows the computer to be a challenging opponent. Section 9. Error handling and input validation. Our code should handle invalid user input. For example, if the user enters spook instead of Spock, the code should display an error message. We can use a try except block to handle this. Python try user underscore choice =, action user choice.eupper, except key error print invalid choice. Please enter rock, paper, scissors, lizard, or Spock. This code ensures that the user enters a valid choice. It prevents the code from crashing due to invalid input. Section 10. Conclusion. Your coding journey begins. This essay taught you how to create a rock, paper, scissors game in Python. You learned about user input, random choices, loops, functions, and dictionaries. You also learned how to expand the game with more options and handle errors. Coding is a valuable skill. It can be fun and rewarding. Keep practicing your coding skills. Try to create your own games or programs. Section 11. Beyond rock, paper, scissors. You can apply the concepts you learned to other games. You can create games like tic-tac-toe, hangman, or even a simple RPG. The possibilities are endless. You can also learn more advanced programming concepts. You can learn about object-oriented programming, data structures, and algorithms. These concepts will help you create more complex and sophisticated programs. Keep learning and keep coding. The world of programming is yours to explore. In this chapter, we will dive into the code and learn how to implement the rock, paper, scissors game in Python. Let's start coding. Pause 2S. First, open your favorite code editor or IDE. We'll begin by importing the necessary modules and setting up the basic structure of our game. Pause 3S. Start by importing the random module to help the computer make its choice. Then, define the possible choices: rock, paper, and scissors. Pause 3S. Next, create a function to get the computer's choice. This function will randomly select one of the three options. Pause 3S. Now, let's write a function to get the player's choice. This function will ask the player to input their choice and ensure it's valid. Pause 3S. Finally, we'll need a function to determine the winner. This function will compare the player's choice and the computer's choice to decide the outcome of the round. Pause 3S. And there you have it. You've just coded a basic version of rock, paper, scissors in Python. But don't stop here. Keep experimenting, adding new features, and refining your code. Pause 3S. Remember, this is just the beginning of your coding journey. The more you practice, the better you'll become. Keep pushing your limits and exploring new challenges. Pause 3S. Happy coding.